This is Geometry Lesson 3.6, as well as a review of slopes of both parallel lines and perpendicular lines. So first we're going to discuss slopes, and here's just a quick practice. So you can see I have 4 lines coming through on this coordinate grid. Remember, slope is rise over run. You can flip these around. Most often you see it as y2 minus y1, x2 minus x1, the difference in the y's divided by the difference in the x's. I personally like to just draw the slope triangle when possible, especially when it's given on a coordinate grid like this. That way you don't have to monkey with the actual coordinates of the lines themselves. So for this tan colored line, you can see it goes down to right 3, so this slope would be negative 2/3. The red line goes up 3/4, so it would have a slope of 3/4. The blue line here, doesn't matter which way you draw the box, 1, 2, 3, 4, down 4, right 3, so it's negative 4/3. And the green line, 3/4, so that's also 3/4. Alright, now we have 2 properties related to slope. So if the lines are parallel, their slopes are equal. If the lines are perpendicular, their slopes have to be opposite reciprocals. And opposite reciprocals would be when you have the opposite sign, so one is positive, one is negative, and then a reciprocal is when you take that rise over run, and it would look flipped. So if we go back to that example, here we have 2 slopes that are identical, so they would be parallel. And then if I were to have the same number flipped and the opposite sign, it would be a perpendicular line. And that shows up down here on the blue line. Negative 4/3 is opposite and a reciprocal of 3/4. So the red and the green line, I could put the arrow marks on, and then between the blue line and the red line, I could put a perpendicular. Also between the blue line and the green line, I could put a perpendicular. Alright, now we're going to be constructing triangles given specific measurements or information. And again, with the constructions, it's only with the compass and straight edge. So here we have 3 sides, and it says construct triangle ABC using the given objects. How many non-congruent triangles can be constructed using these objects? Remember, all the points that are labeled the same must coincide. So point A here and point A here have to be on the same spot. So first we're going to start with just a segment, and I'm going to duplicate. I like to start with the longest one just because then I know I've got enough room for everything else. So I'm going to start with CA or AC, and I'll place my endpoint here. That's where I'll begin from. So I'm taking that distance, making an arc mark. And that would be the base of my triangle, so I'm going to just mark that as C and A. And I'll put the little prime showing that it's not this point up here, but it's the copied point. And then, because I have point C, I could go off of point C, or segment CB next, and that would have to come off of corner C. So I'm going to measure from C to B. Take that down to corner C. And I'm going to make an arc mark. I'm not exactly sure where corner B is going to land because I need to measure AB still. Alright, so my next measurement is going to come off of corner A. I'll measure out to AB. Bring that measurement down to corner A. And I'll draw on an arc mark, and where it crosses the other one, that would have to be where point B is, because that's the correct distance away from C and from A. And then I'll just take my straight edge, connect from B to C, and B to A. And I can mark all of these sides as congruent, so maybe 1 hash mark here, 2 here, and 3 here. Okay, now on this one, there's not going to be another spot where these two arcs would intersect, except for down below, and then I could create the exact same triangle, but just down below. So when it says how many non-congruent triangles can be constructed, there would just be one triangle that can be constructed using 3 sides. Again, it's just because this arc, if I were to continue it, it's not going to meet anywhere else. Okay, so this time I have 3 angles, and I know that a triangle, whoops, when I draw it out, the corners are going to meet so that we've got the 3 sides. So the sides of these angles will have to overlap a little bit, but they don't give me any specific ones that have to have A over here or A over here, so that I kind of get to decide on where those go. So I'm just going to start by creating that starting segment. I grab my compass, and I think I will start with angle A. So place it in the corner, make an arc that goes through A, make that same arc through my segment. I'm going to measure the width of A, and then I will place that same width over here, and I will draw in another side for my angle. And so that would be corner A duplicated. We'll call that A prime. Okay, next one would be angle B. I could do angle C as well. Doesn't really matter. Alright, so I'm going to go over to B. Change the color so you can see this one better. I'm going to make an arc through B. Now, the only problem is I don't have a spot that I have to put it at. So I get to decide where I'd like my point B to start. I could make it right at the end here. I could make it right here. I think I'll do that right here. And I'm going to take my arc. I come right over here. And I would go and measure. Oh, that's a coincidence that it happens to be the same. Place it on the intersection. Make sure it's going to cross my other arc. And then grab my straight edge. Oops, that's a little bit off. Let's try that again. And that would be corner B. Okay, now because my A and my B sides ran into each other, they created corner C for me. And just by eyeballing it, it looks to be pretty much the same size. I could try and duplicate it to make sure it was the same, but I'm going to be pretty confident here that that is corner C. Okay, now how many non-congruent triangles can be constructed using these 3 objects? Well, if you recall, I got to pick where point B was, and so if I had moved corner B out here, the angle would still be going up approximately the same, but my point C then would be up here. And so because I didn't have the limitation of where the side length was, I could make as many non-congruent triangles as I wanted to. So this would be infinitely many triangles that I could create. Alright, this next one is using 2 sides and 1 angle. And if you notice, this angle has corner B, and so do both of these. So what I'm actually going to do here is I'm just going to skip the duplicating angle process. I'm just going to snap a picture of this angle and use that as my pretend duplicated angle. Okay, so I did a pretend duplication, maybe with patty paper. So I've got this duplicated angle B, just to save us some time here. And then I know that both of these segments have to come off of angle B. So what I'm going to do is I'm going to measure AB's length, and I'm going to have that come off of B. And it doesn't matter which side I work it off of, but I just need to have it on one side. And then I'll mark off CB's length on the other side. Still coming off of corner B. So this would be point A here, and this would be point C. And then using my straight edge, I just be able to connect these two to construct the other side of the triangle. So in this one, because I was limited to one angle and two sides coming off, even if I swap these two sides around, it's still going to be the same triangle, just flipped upside down. So with the limitation of the two sides that surround a particular angle, there's only one triangle that I can create. And this one here, we have one side and two angles. And if you notice, this side has the points A and B, and so do our two angles. And so we're going to be duplicating the segment first. And so basically I just want to copy that segment, so I'm going to do that quick and take a picture of it. Alright, so pretend like we duplicated a segment. We have the point A and B. And now I'm going to copy the angle so that it goes off of A or off of B. So starting with angle A here, I'm going to make the arc through A, make that same arc through point A down here, measure the arc's width, and I'll make that same width down here, and draw in my segment my way. I'll go and do the same thing for B. Whoops. So I'll make an arc through B, make that same arc here, measure B's width, and mark that same width down here. And then where the two sides cross, that would be our other corner. Okay, now on this one, because again I had that specific length and these were fixed angles, they can't cross in any other location. This would be the only spot that they could cross. So with the angle of the side and the angle fixed, there would only be one type of triangle that you could create. And here are some more challenging constructions using specific given parts. I'm going to leave this for you for practice during class, and I'll post my answers on the wall. And then the other part of your assignment during class will be practice from the book. So we have some practice on creating triangles and things, and then calculating slope.